Yeah. Okay, so this is the final model what the free Wilson got. Okay, so here there are two values which are given. N is equal to 22 and R is equal to 0.969, where N is the number of compounds in the data set. He has taken chosen for developing this Kaiser model, and R is what is R here? What is R? Am I audible? Last class I discussed about R square, if I remember. What is R? வரதே 17 பேர் 15 பேர் தான் அட்டன் பண்றீங்க. அதுலயும் யாரும் ஆன்சர் சொல்லனா I don't know how to continue. Okay, just check what is R. Okay, so sorry,
correlation coefficient.
Okay, it's a correlation coefficient, right? So how we can make use of this, we'll see a little more about this equation, right? So how we can make use of this equation. Okay, so we can use this equation for predicting the biological activity. Okay, the three major application already we discussed, right? So one is we can understand how the structure is related to the biological activity. Structure and activity relationship, we can use this. The second application of QSAR is like we can use this for lead optimization. Okay, this example is very good example for understanding the lead optimization. A third one is even prior synthesizing the compound, we can calculate what will be the expected biological activity of the new compound. So these are the three ways by which we can make use of this QSAR equation, right? So what he did is, for so we have 22 compounds that was taken by the free Wilson for his analysis. So here we have two more column. Okay, this is a very important column for understanding the predictive power of his model. Okay, this column corresponding for the observed value. Okay, the observed value is OBS is the experimental value. Okay, it's a wet lab technique. We have to calculate, we have to do the experiment to find out what is the experimental value. Okay, so next is the calculated value. So which means that the values given in the third column, okay, those are the predicted value. Okay, so again I repeat, right? So you should not get confused. Two values, both the values are log 1 by c biological activity. The values in the second column is the experimental value, which is given as observed value, and the value on the last column, third column, is the calculated value, which means that predicted value. Observed is equal to experimental, calculated is equal to predicted. Okay, so how to calculate observed? We know that we have to calculate this observed value using the experimental method. So how to calculate the predicted value, the values in the last column? It's quite simple, right? So his data set is having 22 compounds. First, what we have to do is we have to create the model for 21 compounds by eliminating the first compound, which means that the first compound is not included in the data set. We had assumed that the molecule is removed. Okay, so remaining will be having 21 compounds. So for the remaining 21 compounds, we have to develop the model like this. Say now the n is equal to 21. Okay, so we created this model based on 21 compounds in the data set. Okay, so actual data set is 22, but we are using only 21 compounds for developing this model. So remaining we have one more molecule, for which we already know what is the experimental biological activity. Okay, this time what we are going to do is, to this model we are going to input the descriptor values. Okay, so already I told that we can calculate the values of descriptor using different software or different experimental method. So using of this method, we have to calculate for this one compound, we have to calculate the descriptor value. Okay, then we have to input the descriptor value to the equation, and the equation will, this model will output what will be the biological activity of that model. that is the predicted or calculated value. So in such a way, what he did is we calculated, he estimated the predicted value for all the 22 compounds in his data set. So for the first molecule, the experimental value is 7.46 and the predicted value with the help of the model is 7.82. We can say both the values are very close. So for the second compound, the experimental value, the observed value is 8.16, predicted value is exactly 8.16. Third compound, the observed value is 8.68 and the predicted value is 8.59, very close. If we compare all of the values, right? So for the entire molecules in the data set, 22 compounds, the observed value and the calculated values are very comparable. Okay, so which means that the equation what he developed, this equation, is having a very good predictive power. Okay, we can say that since for the training and test data set, the equation is able to produce the closer value for the observed and calculated, which gives confidence that this model is a very good model. We can use this model for a molecule which is not yet synthesized, and we can predict what will be the biological activity of that molecule. Is it understandable?
Yes, sir.
Yes, right. So that's thing, right? Uh, okay, so we will take this equation again for understanding few more things, right? So already you know what is meant by n is equal to 22 here, and r is equal to 0.969, which is a very good, the correlation coefficient is a very good value. 0.969 is very good value, right? So I'll talk about the n r square later, right? So let me tell that anybody know what is this value? 0.454, the coefficient of the descriptor. So here the first descriptor is m at meta position. Okay, we cannot call it as a descriptor. So according to Free Wilson, the overall biological activity is just the contribution of each functional group which are present, right? So in that way, these are the various functional group. Can you tell what is the coefficient of this functional group? F at meta position, M at CL at meta position, BR at meta position. We have some coefficient values like 0.301, 0.207, 0.434. Any idea what is the value? I'll be waiting till I get some answer. Okay.
So log P value.
Can you say again?
So I don't know whether it's a log P value.
How come that is log p value? In this equation, we don't have any component like log p. This is an entirely different type of equation, right? So I'm talking about, I'm not talking about the Hunch equation. So this is a Free Wilson idea. So according to his idea that the overall biological activity is just going to be the contribution by each substituent. So already I have shown the data set to you. Okay, so this is the data set what he has used. Okay, so the possible, the substituents at X and Y position are F, H, Cl, Me at the meta position, H, F, Me at the para position. In that way, we can generate many number of compounds. Okay, so he took 22 compounds in his data set, and he compared the observed value and the calculated value, and both the values are very closer, gives some confidence for him that his model is having good predictive power. So my question of interest is that, so this is the equation given by him. What do you think is the coefficient for the substituents? So here the substituent is this F at meta position. Okay, before that we have coefficient 0.301. You have to remember that already I gave the equation, free Wilson analysis equation also, right? So you have to
Weight of
correlate everything. Weight of,
substituents.
yeah,
Substitutes.
who is answering?
This may ask.
Yeah, this is called as the weight of substituent, right? So already the values given in this table 0 1, this is what's the name for the for this 0 1?
Indicator variable, sir.
Indicator variable, right? So in his equation, that is the indicator variable. The 0.301, 0.207, 0.431. Let me erase this for better clarity, right? So these are the values which are called as the weightage of each substituent according to his concept. So which means that for the overall biological activity, so for the overall biological activity log 1 by C. Okay, so the F at meta position is contributing, and its contribution is 0.301. It's just numerical value. So the Cl at meta position, if the Cl is at meta position, its contribution for this overall biological activity is going to be 0.207. And if the Br at meta position, its contribution for the overall biological activity is going to be 0.434 and so on. Is it understandable?
Yes,
So
sir.
this is how each substituent is contributing for the biological activity. Okay. So a few more points we have to discuss with this equation, so if you carefully look at the equation, few things we can infer from this. The first thing is that, so okay, so let me ask you a question, right? So it'll be easy for you to understand if you answer this question. So here we have F, we have Cl, we have Br, we have I, and we have Me. Right. So totally, how many number of functional groups you have? Say 1, 2, 3, 4, and 5 functional group, right? So you know what is meant by lipophilicity, right? Can someone define what is lipophilicity?
Lipid loving, sir.
Okay, so that is not definition. Okay, anyway, lipid loving, right? So fine. So we discussed about lipophilicity of functional group. Do you remember? In one lecture, I have differentiated. I explained the difference between log p and pi. Do you remember? I told that log p is the lipophilicity of the entire compound and pi is the lipophilicity of the substituent. Am I right?
Yes, sir.
So can you check what is the pi value, lipophilicity of F, Cl, Br, I, and Me quickly? Definitely you cannot answer on your own. You have to do the Google search and find out what is the lipophilicity of F, Cl, Br, I, Me. I mean that what is the order of lipophilicity at least? Which one is having the highest lipophilic nature? Which one is the next? Which one is the next? The order of lipophilicity of I, Cl, Br, F, and Me. Can you do a quick search and come up with the answer? Because that will be useful for the discussion. So you can do the search and let me know the answer, right? So before proceeding. So anybody got the values? So anybody got the values?
So the value didn't show the
Yeah.
cursor, but it shows the same order of expression. Value, sir.
What's the value? Definitely there should be some difference. Fluorine, chlorine, bromine, iodine, all are not same. The electronic configuration of FClBrIme differs, right? Obviously, they cannot have the same or equal amount of lipophilicity. There will be kind of difference in the lipophilicity between all the five groups. Okay, you may take it as a homework, right? So I'm running out of time, right? So you may take it as a homework. So the point is that the first point is that the biological activity increases with the lipophilicity, right? So you just check what is the order of the lipophilicity, right? So we'll make the discussion then. Second one, we can easily answer. The biological activity increases with electron donor ability, right? Can you tell what's the order of donor? What's the order of electron donor ability of FCl, Br, I, and Me? Which one is very strong electron donor? Electron donor properties of FCl, Br, I, and Me. Which one do you think is a strong electron donor? You can very easily answer this question. Again, I am waiting for your answer. My question is, which of the following is very strong electron donor? That's my question. Okay, if you answer, I'll proceed further. Is my question understandable?
Yes, sir.
Can you say my question? No.
Which of this is a strong electron donor?
Yes, that's my question. Okay. What is the answer? Should I wait for another 15-20 minutes for getting answer for this question? Even if I ask a 8th standard or 9th standard student, they can answer this question in 30 seconds. Okay, you people do the search and come up with answer. Okay, I'll wait. Not an issue. F, Cl, Br, I all belongs to the same column of the periodic table. Me, many times you might studied about Me group, methyl group, CH3. The question is straightforward. Such a simple question, anybody can answer. Which of the given atom element is a strong? Which of the element or atom or group of atoms strong electron donor? That's the question.
Yummy, sir.
Yes, sir means
Ye-
huh?
Yummy metal group, sir.
Huh?
Yummy is a strong electron donor.
Who is answering? I think only one student is attending my lecture, right? Who is answering? Vishmaya.
Yes, sir.
You right?
Yes,
உங்க
sir.
கிளாஸ்ல மீதி பேருக்குலாம் பேச வராதா? ம்? ஊமையா? ம்? காதுக்கு கேக்குறது பேசுறதுக்குலாம் வராதா மேடம்?
Sir.
ம்? இல்ல நான் உங்க கிளாஸ்க்கு வந்தது இல்ல, அதனால எனக்கு தெரியல. மீதி பேருக்குலாம் காது கேட்காது பேசுறதுக்கு வராதான்னு கேக்குறேன். ம்? நாளையில இருந்து நான் என்ன பண்ண போறேன்னா செஷன் ஸ்டார்ட் பண்ணிட்டு உங்கள மாதிரி அப்படியே அமைதியா உட்காந்துக்க போறேன். நீங்க சார் சார்னு கூப்பிட்டுட்டு இருங்க, நான் உட்காந்துட்டு பார்த்துட்டு இருக்கேன். ம்? இல்ல செமினார் வச்சுக்கலாம் நாளையில இருந்து டாபிக், சரியா? அது இன்னும் நல்லா இருக்கும். ம்?
Sir.
என்ன மேடம் ஒரு பேசிக் கொஸ்டின் வந்து எஃப்சிஎல் பிஆர்ஐ எம் ஏதாவது சப்ஜெக்ட்ல இருந்து கேட்டா பரவாயில்ல. கேட்கறது ஒரு ஃபண்டமெண்டல் கொஸ்டின். அதுக்கு வந்து அட்லீஸ்ட் தப்பா ஆன்சர் சொன்னா கூட ஓகே. ஆன்சரே சொல்ல மாட்டேன்னு உட்காந்துருந்தீங்கன்னா எவ்ரிதிங் வில் பி ரிஃப்ளெக்டட் ஆன் சம் வே. ஓகே. ம்?
Yes, sir.
நியூட்டன்ஸ் லா தெரியுமா? ம்?
Equal
Anybody
and
know Newton's law? Third law. You know the third law, right? Can you state what is the third law of Newton's?
that is an equal and opposite reaction.
For every action there will be equal and opposite reaction. ஓகேவா? ஏதோ ரொம்ப ஜாலியா நீங்க அப்படியே பேசாம உட்காந்து சந்தோஷமா இருக்க மாதிரி நினைச்சுக்காதீங்க. ம்? இப்படி சொல்லியும் அடுத்தவங்களுக்கு வாய் திறக்கிறதுக்கு வரலன்னா என்ன மாதிரி கிளாஸ்ன்னு எனக்கு தெரியல. யாராவது ஸ்பெசிஃபிக்கா கேட்டா என்ன சொல்ல போறீங்க? எனக்கு பேக்ரவுண்ட்ல நாய்ஸ் இருக்கு சார், என்னோட மைக்ரோஃபோன் ஒர்க் நான் வந்து மொபைல் ஃபோன்ல கனெக்ட் பண்ணியிருக்கேன். Okay, let me ask specifically to some students, right? So no other option. Who is Kavya Karthik? Madam, you can unmute, madam. This is not the way to answer, right? Can I teach you by chat box? என்னென்ன சொல்லணுமோ அதெல்லாம் chat boxல டைப் பண்ணிடவா? ஃபுல் லெக்சரையும் பாத்துக்கிறீங்களா?
Yes, sir.
Anyway, okay உங்களுக்கு அந்த மாதிரி டைப் பண்ணா?
Sir, I mean, I'm Kavya Karthik.
You are the Kavya Karthik, madam. If I call you, you have to unmute and talk. Okay. Now 40 minutes lecture நான் டைப் பண்ணா உங்களால பார்த்துருக்க முடியுமா? புரியல எனக்கு. Okay, what is the answer for my question? Tell. Madam, the question is, specifically for you, what's the answer for my question? So I'm showing, 5 functional groups, F, Cl, Br, I, Me. My question is which of the following given donor group and why?
Sir, your voice is breaking, sir.
Is my voice breaking for others? No, it's okay.
No, it's okay, sir.
எல்லாத்துக்கும் எல்லாரும் ஒரு ஆன்சர் தெரியலனாலும் ஒரு ஆன்சர் வச்சிருக்கீங்க ரொம்ப கிளவரா. ஓகே, who is Preeti?
Sir.
Yeah, what's the answer for my question?
Sir, ME, sir.
Me, why? How do you say me? How do you say the answer is me? There should be some explanation, right? Madam, are you there?
Yes, sir.
Yeah, you had to answer. At least you can try to answer. I don't know how you said me. That's fine. Okay, so maybe that's the correct answer. What I need is, what's the explanation for saying that me is the strong electron donating group?
Sir, out of all the groups, it has the highest charge, sir.
So me is having highest charge, right? That is the answer, right?
Yes, sir.
Okay, you can mute your microphone. Sharmila,
Yes, sir.
what's the answer?
Methyl, sir.
How do you say it is methyl? How do you say that it is methyl? Everybody is saying methyl. So I need the reason for saying methyl is the correct answer. Sriram. Anybody join with the name Sriram? Subramaniam?
Yes, sir.
Yeah, what's the answer?
Methyl, sir.
How do you say it's methyl?
Because it has more electronegativity.
So you mean that the electronegativity of methyl is more comparing to FCl Br high?
No, sir. F has more
In the periodic
electricity.
table? No. Just
F
you
has more
only said no.
electron. Yes, sir.
Okay. Just you said you only said CH3 is more electronegative than other groups. That's why I'm asking. Is it so? So how many boys in your class?
10, sir.
How many boys in your class?
I guess 10, sir.
You guessed 10, right? So why only one or two students attending for all the lecture? What about the other 8 or 9 students? Total strength is I think 50. Today we have 17 students.
Yes, sir.
Already I registered my complaint against your class. Okay. So as I said that everything will be reflected in some way. As a teacher, right? As a student, your duty is attending the class. If it is very unexpected situation, that's fine. Okay.
Yes,
So
sir.
if out of 50 students, if only 15 students are attending the class, I don't know what's the point.
Sorry, sir. It won't happen again. We'll be
No.
attending regularly, sir.
I'm not. You are no way related to that. Just I'm
Yes, sir.
telling. Okay. Since I'm able to see only 8-9 girl students regularly. That's all. I don't find any boys. I don't think. Anyway, I have collected the last 10 lecture class attendance. I have submitted that to my head of the department. Okay. So the average class strength for this course is only just 15 for all the lecture classes, not more than that. Sometimes maximum 20. I don't know what happened for the other 30 students. If you don't attend the lecture class, I don't know how you will pass this paper. Already I mentioned that I'll never compromise the standard of the question paper. Never. You cannot find answer for any question, any internet resource. That is the way how I used to set the question paper. This time also not online, right? So maximum you have to come to the campus and write the examination. That's the idea proposed by the management already. And for this course, I opted for the regular traditional examination method. If you people don't attend, if you people don't answer for any of my question, I don't know how you are going to prepare for the examination, how you are going to write the examination, how you are going to pass this paper. Everything is I don't have any answer for any of this question.
We'll attend regularly, sir.
See, already 2-3 classes. I know I mentioned this. This is not the first time I'm telling this. Even if I ask 8th or 9th standard student, what's the reason that methyl is a strong electron donating group? They can definitely answer. It's not big science.
Yes, sir.
Okay. Do you have answer for my question? So how do you say that methyl group is strong electron donating group? So initially you said that it's a strong electron, it is having electronegativity, but now that's not the correct answer, right? Because FiCl, they are more electronegative than CH3. So anybody in this room, anybody joined for this session can answer.
Fluorine has more electronegativity, I guess.
Okay. Anyway, that's not my question. Electronegativity is not my question. My question is, how do you say that methyl group is a strong electron donating group? And the question is not only for Subramaniam. It is open for all. Anybody can answer this question. Any of the 16 students who has joined for this session, they can answer this question. And no, every question I'm noting down who is answering, right? I have the data for whatever question I ask, who is answering. Yes, anybody can answer. Yes, Subramaniam, you can mute your microphone. If anybody knows the answer, anybody can try to answer my question. Yeah.
Sir, CH3 is the electron donating group because others are all electronegative.
Okay.
CH3 can donate the hydrogen atom and form double bond.
CH3 can donate.
CH3 has the hydrogen atom, so that can be donated. So that's the electron donating group among the five.
Mm-hmm. Okay, so the electron donating property of the CH3 is better comparing to other because all other groups are electronegative group. Am I right?
Yes, sir.
So the nature of electronegative group is it will try to pull the electron towards it won't easily give the electron. Am I right? So they are called as electron withdrawing groups. And among these five, the only electron donating group is CH3 group, right? But the order of electron donating ability of all the five functional group will differ. Yeah. So if you look at this, CH3 group is the most electron donating group, and the contribution of the electron donating group, the coefficient here, this 0.301, this 0.207, 0.434, 0.579, 0.454, so on, right? So these are the values which are called as regression coefficient. So just like the correlation coefficient, these are the values which are called as regression coefficient. So according to Free Wilson, the regression coefficient defines what's the contribution of that specific functional group for the overall biological activity. So if we compare the regression coefficient of different functional group, okay. So if you look at this for methyl at meta position, the value is 0.454. But at the same time, if you have the methyl group at para position, the value is 1.256. So if you have F at para position, the value is the coefficient is 0.340. Which one is having higher value? Methyl at para position or fluorine at para position? For which one the coefficient is having the higher value?
Methyl at para position.
Okay, so can we say that methyl at para position is contributing more for the biological activity than fluorine at para position?
Yes, sir.
Yes, right. So that is what we can understand. Okay, the biological activity increases with the electron donating ability. So okay, one more question is if I change this methyl at para position to a more electron donating group at para position instead of methyl group, if we replace with a very strong, even stronger comparing to the methyl group, what will happen for the biological activity? Again, I repeat my question. So methyl at para position is contributing, there is some amount of contribution for the biological activity, which is given as 1.256. Is the regression coefficient. If I change this methyl at para position to a more stronger electron donating group, what will happen for the biological activity?
It will increase.
Okay, the biological activity will get increase. Are you able to understand? So in this way, can we say that this equation can be used for lead optimization procedure? What is lead optimization? Making changes in the structure to increasing the biological activity, right? So this equation can be used as guidelines for the lead optimization, right? So that's one point. Then okay, so here we have the substitutions at two position. One is at the meta position, another one is at the para position. So wherever you have m, okay, so that is the meta position. So wherever you have p, that is the para position. So the first row all the substitutions at meta position, and the second row all the substitutions at the para position. Okay, para 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 para. So the point which is given here is meta substituents contributes less than the para position. So if we compare the same methyl group at meta and para position, so we are taking only these two groups for understanding. So the same methyl group is present at the meta position. Also the same methyl group is present at the para position. But the contribution of the methyl group at para position is 1.256. But the contribution of the methyl group at meta position is just 0.454. At which position the methyl group is contributing more for the biological activity? So can we say it's contributing more in the para position?
Yes, sir.
So if we compare the same thing with the I, right? So I at the meta position, I at the para position. So in which position I is contributing more, at meta position or para position?
Para.
Para position. So similarly, if you compare for all other B or CLF, all the cases we can say that the contribution of that specific functional group at the para position is more, or we can say another word that meta substituents are contributing less than the para substituents, right? So those are the things what we can infer out of this equation. Okay, so what we do is, I'll tell how to read a Kaiser equation, how to infer the information out of the Kaiser equation, right? So the first equation is biological activity. So so far what we discussed is log 1 by c as a biological activity. So here it is not log 1 by c, so they have taken log k. So can you tell what is this k? What is k?
Dissociation constant.
Okay, dissociation constant, right? So in this example, the drug molecule that binds to the receptor, okay, is a hydrophobic pocket of the receptor where the drug molecule should go and bind, right? So in this case, they have taken this dissociation constant as the biological activity. So they have taken log k as the biological activity. So log k is equal to, so we had read this equation, 0.33 log p plus 0.24 pka plus 1.48. Okay, so here they have given some number. These are the numbers related to the statistics. So n is equal to 15, r square is equal to 0.90, and s is equal to 0.090. So can you tell what is n? Many times we discussed about n. What is n?
Number of compounds.
Okay, so total number of compounds 15. What is r square? Correlation coefficient 0.90. What is s in statistics? What is s? What is s in stat? Okay, yes, here is the standard deviation whose value is 0.090. So this value should be as less as possible for the good model, right? So we discussed about n by 5 rule, if you remember. So if you apply this n by 5 rule, so 15 by 5, which is equal to 3. So maximum number of descriptors we can use. It's a rule of thumb, right? So no need to follow this strictly. This gives some kind of guidelines. Okay. So the maximum number of descriptors that we can use in this equation is 3. So can you tell how many number of descriptors originally used in this equation? How many number of descriptors used in this equation?
மேம் 10 நிமிஷத்துல வந்தாலும் நீ சீக்கிரம் வந்தாலும் மேம் எடுத்துட்டு போவாங்க உனக்கு தான் வெயிட்டிங்
Am I audible?
Sir, one.
Okay, so 2 answers are coming now. 1, 2. Who said 1?
எல்லாம் போனாங்க
Sir, hydrophobic descriptor.
Who said 1?
இல்ல மேம் RAT
Sir, Janani, sir.
Yeah, can you tell what's the name of the descriptor?
நான் வெளியில போயிட்டு
Sir, log P, hydrophobic.
Log P is the descriptor. Okay, now I am not asking anything else. Log P is the descriptor, right?
Yes, sir.
Who's that 2?
சுஜாதா
Somebody answered 2. Yeah, what are the descriptors? Can you tell?
Log P and pKa.
Log P and pKa, right? So in this, they have used 2 descriptor.
சுஜாதா
The first descriptor is the log P, second descriptor is pKa. Is it understandable?
Yes, sir.
So how many descriptors according to n by 5 rule we can maximum use in this equation? We can use 3 descriptors, but how many they have used? They have used only 2 descriptors. Is it understandable?
Yes, sir.
Yes, right? Okay. So coming to this, so using the n, we can apply n by 5 rule to say that whether the equation is, good in terms of number of descriptors used. So coming to this r square, the r square value should be closer, very closer to 1. So in this 0.90 is very closer to 1. Okay, we can say that the model is a good model in terms of statistics. So the standard deviation value should be as less as possible. So we are able to see that the value is 0.090. Again, the value is considered as very less in terms of the numerical value, right? So based on that, we can say that the model is a very good model. Okay, the model is a very good model. The predictive ability of this model is determined using this r square value. 0.90 gives confidence that the model is a very good model. So can you tell what is the regression coefficient for log P and what's the regression coefficient for pKa? What is the regression coefficient value for what's the regression coefficient value for log P and what's the regression coefficient value for pKa? Is my question understandable? Somebody can respond. Just in the previous slide, I have told that what is the meaning of regression coefficient. I am taking another example, that's all. Okay, I don't think I'll get the answer. We will see in the next class. Okay.